And the hip extension, this is going to be done for 6 weeks, 3 times a week, 3 sets of 10, and they're going to have 2 minutes between sets, and for the individual joint training, they're going to get 5 minutes of break between exercises. The resistance is determined to be the 75% of their 1 repetition max, which we found out on the first day. And although the individual joint training has more exercises than the whole leg training, the net torque is the same, so no one method is going to increase strength more. And allow me to hand it over to Steve to talk about the training.
Thank you, Jared. Okay, so we have the 3 tests that we will be doing both before, prior to the training sessions, during and afterwards as a post-test. The jump test, stabilimetry test, and the perturbation test. And for these tests, we have a lot of equipment. So a force plate measures ground reaction forces. Motion analysis system is a set of cameras. They're infrared, and they pick up reflections of light. So we have reflective markers on our participants. And then the perturbation device, you can see it up here. And that is just pretty simply a pendulum with a ball on a wire, and it will spin and strike the participants in their upper back so that they will be perturbed. So this is a very big overview of our tests and what they will be measuring. So the jump test, participants will be standing on a force plate, and they will be asked to put their hands across their chest and jump as high as they can. And this will be measuring strength, and we know this because strength is generally defined as the maximum force you can generate. So we'll be looking at the power output for that. And then we have our 2 balance tests, so stabilimetry and perturbation. For these tests, we're looking at variance. So similarly, stabilimetry, they'll be standing on the force plate and they'll be asked to not move, and we will be able to measure their variance within their center of balance. And then for the perturbation, same follows. They'll be standing there, except they will be standing in front of the perturbation device. When they're perturbed, we'll be measuring their variance as well, but we'll also be looking at their center of mass displacement and the center of mass return time. So we want to see how far they're moving outside of their center of gravity, and also how long it takes for them to return. So the strength test will prove the initial hypothesis that all training will increase strength, so we want to make sure that that is indeed happening. The stabilimetry test is looking at just standing balance, how does somebody, their general overall balance, and then perturbation is looking at what happens if you do experience trauma or you trip, how would you recover? So with that, the delta variance is looking at the difference between the good variance and the bad variance. So good variance would be motions of your joints that would maintain you inside your center of balance, whereas bad variance is where your joints will push you out of that boundary. So we're looking for more good variance, less bad variance. So the ratio with more good variance would give us good synergy, something that gives you your balance, and bad synergy would be a higher ratio of that one of things. So I'm going to move on. So right now we're doing a pilot test. We're almost complete with that, and basically some of us are participants and others are testing, some are training. And we're not using this for data, we're more using it to finalize our methodology, since it's so complex and we have a lot of equipment and technology we're not familiar with. So we have learned that for training, we need to emphasize organized scheduling. We need to make sure the machines are always set at the right weight, and that we need to track the progress of the participants as they are in the room training, since the sessions go on for a pretty long time. For testing, we need ample preparation time. It's really complicated to set up the motion analysis system, and we also need a block and noise perturbation so that they're not aware that it's coming. And we will be able to use our data to kind of practice our analysis. So this is where we stand right now. We have gotten our IRB approval, and we hope to test subjects in the spring. So we're going to be recruiting them following junior colloquia. And eventually, senior year, we will be writing a paper and publishing. That's our hope. So our team is made up of 9 members, and none of us come from very technical fields. So this has been very new for us. We also have weekly team meetings and subcommittee meetings. We have data measurement analysis. We have more logistical, administrative, and testing, and then the recruitment and training team. And so our advice for the next generation of Gemstone students is to be constant and prompt with your communication. That's been our biggest struggle as a team. Also to maintain reference documents. We find that we are not always on the same page. Maybe with an idea of something, so make sure you have a record of where you stand with your project. Work to everyone's strengths. Everyone has their niche, and be accountable and make your meetings productive. Also, during summer vacation, winter break, make sure you're continuing moving forward, because that's a lot of time that you can utilize. So finally, we'd like to acknowledge our mentor, Dr. J. Shim, our librarian, Dr. Svetla Bakusheva, Dr. James Wallace, Rebecca Thomas, Vicki Hill, Dr. Lindberg, Tom Harris, and the Gemstone program staff, and of course our audience here. So if you're interested, you can contact us. And thank you for listening. Any questions?